Good morning, everybody. In talking with the 8th grade advanced math teachers, they really want us to focus on scatter plots and two-step equations with you for the rest of the digital learning time, because that is where they want us to focus there in slope. So we're going to start today with Scatterplot and Association. I went ahead and wrote all these notes out to save time, so I'll just be sliding the paper and writing things out to the side as I go. I do recommend that maybe you get some paper and pencil yourself and take notes, because you will have some homework in the discussion post on Canvas that you'll have to answer, and it's going to be regarding everything that I'm going over right now. Okay, so without further ado, my dears, let's get started. First, before we do get started, I miss y'all so much. I hope you all know that. All right, let's get started. All right, so scatterplots and association are graphs that display numerical data. Okay, so it's got to be numerical data, and it's got two variables that we're going to be talking about. And another word for two variables is bivariate data. And you guys know that I'm an ELA person too, so I like to explain that words tell you what it means. Bi means two, like bicycle, bipartisan, biweekly, bimonthly, and variate is a word from variables. So two variable data, okay? Scatterplots help determine if one variable has an effect on the other. So as you put your data down on a graph, you can look at it when you're done to see if it has an effect on each other. And some of those effects could be, are there trends? Do you see something happening with this data that is considered a trend? Are there patterns? Do you see a pattern forming? And is there an association? Oh, look, it's in a different color, because that's what we're talking about. See, we're talking about scatterplot and association, and here's that word again. Is there an association at all between these two variables, the bivariate data that we are plotting on a paper? Okay, so just some vocabulary, just some idea of what it is that we're going to be talking about, okay? Hold on one sec, let me skip to another paper. Okay, here's the question we're going to be looking at, and hopefully this will all make sense once you start seeing it on paper. All right, so let's say Susie went to the mall and surveyed shoppers, that should have an S, sorry, to see how many items they purchased and the total money they spent. Okay, then she created this data, or this graph below from the data. So I'm going to go ahead and show you the data that I've gotten. All right, so before we get started with anything with this graph, we are missing some very important information. And I hope that you all remember when we were doing slope that you have to do what before you can start a graph? Does anyone remember? Anyone? I'll give you a second to think about it. You have to label everything on your graph. Otherwise, these numbers mean nothing. What do these numbers mean? Well, who the heck knows, because we don't have anything labeled right there to tell us. What does this mean? Well, we don't know. We can figure it out, though, from this question. But if you just saw this graph just like it is, without that information, you would have no idea what we're looking at. So we need to do like mall shoppers. Mall shoppers, you could title it whatever you want. Mall shoppers and money spent. And then we have to label our X and our Y value. Our X value right here is going to be the people, the number of people, okay? Oh, I'm sorry, not people, number of items. See, even I got confused. Number of items purchased. And what will our Y values be? Anybody remember? Yeah, very good. Money. Awesome job. How much money was spent, okay? So as you can see, when we're creating a scatter plot, our data is not going to be done in a straight line. It wouldn't make sense. This is a scatter plot. Our information is going to be scattered throughout the graph. We need to see it scattered everywhere. This means that one item was purchased, and when that one item was purchased, it cost this shopper $40, and it cost another shopper around $90, okay? So that's what this means. She surveyed people. How many people did she survey? Does anyone know? Because that is our next question, and we do need to understand that. How do we figure out how many shoppers were surveyed? Anybody have an idea? I'm going to give you a second to think. You count the dots. The dots, each dot represents one shopper. So as you count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 shoppers were surveyed. And I would normally put this in a sentence, but I am going to not, because it's time. Okay. So let's look at the graph. What do you notice? Is there an association? Because that is our next question. Oops, sorry, let me get rid of my notebook. Does it seem that the items have an effect on money spent? Well, look at what's going on. As our items are purchased, as more items are purchased, what's happening with the amount that's being spent? It's going up, which makes sense. It would, the only reason like a number 1 item would be more than number 10 items is if you went to the Dollar Tree here and you went to a furniture store here. If you bought one bed, obviously the price is going to go way up. And if you buy 10 items from the Dollar Tree, it's only going to go to $10. So obviously they didn't do this at the mall. One item costs 50 or 40, one item costs 90, and as you buy more and more items, obviously your price is going to go up. Okay, so it does seem like the numbers have an effect on each other. I'm gonna have to use my foot. This would be so much easier if I had an in-home recording studio, but I don't. Okay, does it seem the items have an effect on each other? Yes. The more items bought equals more money spent. Ooh, that's terrible. I'm sorry. Sorry for my foot. Okay, so I hope that makes sense to you. I'm going to slide it over, and we're going to talk about types of associations now. Okay, so there are 3 types of associations, and the first is positive. Let's always start with the positive. The positive is when the variables move together. As one variable increases, so does the other. And as you can see, I put mall survey in there because that's what this is. As you can see, as our items increase, our money is going to increase. So this would be what we call a positive graph. And if you remember from slope, remember we talked about, is it a negative or a positive slope? And it's like when you read a book, you start from the left, you go to the right. And if our graph is going upwards, that creates a positive slope. Same with this. This is a positive association, okay? Because as we go up with one, we go up with the other. As one variable increases, so does the other, okay? As X increases, Y increases, okay? What do you think our next one's going to be? Anyone? Negative, very good. All right, the variables move in opposite directions. So where this one, they're moving in the same direction, this one is going to be moving in opposite directions, okay? As one increases, the other decreases. And I put in here absences and grades. Think about if you're absent a lot. If you have more than 20 absences in a year for school, that is most likely going to affect your grade. It's very difficult to try to catch up when you're out so much. And it just makes sense. It's not like that for everybody, but for most people, as you are absent more, as we go this way, remember our numbers are increasing, but look at what happens with our Y values. So let's say this is representing right here 10 absences. Well, if you are absent 10 times, your grade is going to drop according to this graph. So as one increases, the other is going to decrease. This has, and as you look at our graph, reading it from left to right, we are going down and we have a negative association here. Okay, the third one is no association. The variables have zero effect on each other, okay? Whatever one variable is doing, it has no bearing on the other. And one I like to give as an example is your student's last number of your phone number. So if we were in class, and I really wish we were because we'd have a gallery walk doing this stuff, if I asked you to go and survey all the students in the class and ask them what their last digit of their phone number is, it could be all over the place. This has no association. As we are reading left to right, we are not going in a negative, we're not going in a positive, it's all over the place. So this is no association, okay? The last thing I want to talk about with scatterplots and association is there's also ways we can classify this. We can classify them as strong, weak, linear, and nonlinear. And as you remember, linear is a line, okay? Nonlinear is no line. And this is really a quick thing. You should be able just to look at something and tell very quickly. If we're looking at this, we see that it's a positive scatterplot association. And we want to identify, is it strong, weak, and then identify if it's linear or nonlinear. So as we look at this, do you see how all of the data is very close together? It's very centralized. They're very, very close together. This means that it is a strong association because all of our data points are so close together. And linear or nonlinear, this could, if I were, or if I needed to, I could draw a line going through this data right here. Oops, I'm sorry, right here. And we're going to be talking about that too. It's going to be called line of best fit, but this is a linear, strong graph, okay? Let's look at this one. As you can see, the difference between this and this is that our data is not as concentrated. It's more spread out. If you're talking about science, this could be like it's more diffused because it's more spread out. So this could be concentrated and this would be non-concentrated. And if you're, Mr. Jones does that a lot with you guys. This also, if I could draw a line through this because I can see that the data is going in a upward motion. It's a positive association. So this one would be considered weak because the dots are so spread out from each other, but it is still considered linear. Okay. Looking at this one, our data is very, very concentrated once again. So it is still strong, but if I were to draw a line through it, look at where all my data is. Even if I were to go this way, not all the data is falling on that line. The data dips way down right here for some reason. So this would be considered a non-linear association. It's strong, but it's not creating that line that we're looking for. This one right here, what do you think? Strong, linear, because I could technically draw a line going down the middle of that, and all the dots are like being drawn to that line. Okay, what about this one? This one is going down, but it's not really in a line. So this would be, and the data is kind of all over, so it'd be weak, non-linear. And I'm abbreviating. I hope you understand why. Okay, and the last one I want to look at is right here. This one obviously it's nothing. It's got no association. You can't draw a line. You can't draw a line. It's not strong. It's not weak. There's just no association there. Okay. I'm going to put some examples on Canvas for you in a discussion post, and I would like for you all to discuss these graphs and situations as being either positive, negative, or no association, and are they strong, weak, linear, or nonlinear? So kind of what we're doing right here, and I forgot to tell you these were positive, strong, linear, positive, weak, linear, positive, strong, nonlinear, negative, strong, linear, negative, weak, nonlinear. I did forget to put that in there. This is basically what you're going to be doing with the situations that I give you today. And then I want you to try to come up with some of your own situations on positive, linear, and negative, linear. Okay, and even some no associations. I want some examples from you guys. Watch this video again if you need some help. I know it was fast, but I got to put these videos up and I can't make them too long. I love y'all. And you also have a breakout game on Marvel characters for what we did last week. Okay? Have a great day, everybody. And you know how to contact me if you have any questions through Remind, email, or Canvas. Have a great day. Bye-bye.